Okay, guys, here we go again. We're going with our next lesson, which is exponential function graphs. We're gonna skip the cubic function because we kind of saw it a little bit when we did square uh, root functions. So I'm gonna just skip like cubic and we're gonna jump to exponential function because these one are more I guess not important, yes, because you're going to see this down the road in different classes, like geometry, algebra 2, cubic function, you'll see that, but that's like, I guess, easier because like I told you already, we already saw that before in the previous lesson. So we're not going to dedicate one lesson just for that. So, because time is precious now, so we're going to jump. Now, exponential functions. The word exponential means that the graph grows faster, okay? A quadratic, it grows, not as fast as the exponential. A line usually goes at a constant rate. So when you graph a line, it's going to be the same slope, same rate. But when exponential, the rate is graded, okay? So you'll see that when we graph, okay? Now, I already wrote here for you also, what you need to know to put a exponential graph in the calculator. Remember, I'll show you how to do absolute values. I'll show you how to do square root and cube root. Now we're gonna do exponentials. So, with the difference with exponential and the other one is now that the variable x becomes exponent. That's what is called exponential. Because in all the other ones before, the x always goes like on the bottom, if you can say that, like the parabola, right? The parabola, the main function is y equals x squared, okay? This is what I'm talking about, okay? Y equals x squared. If you notice, the x is the base and the square is the exponent. This is a quadratic, okay, function, which the graph can be a happy face or sad face. But look here now, in here, the x becomes the exponent. Even when you have y equals mx plus b, that's a linear function. You don't need to have exponent. The exponent there is 1. So if you notice here, this is going to be the parent function, okay? Remember that the parent function is usually the main function. Because remember, something's gonna happen when we do transformations. Whatever you add to this parent function, it turns in a different function, all right? So some things, it moves to the left, it moves to the right, up, down, it gets bigger, it shrink. There's so many things that happens when you add other factors to a parent function or to the main function. So to begin with, they're asking us to complete the table and to graph. Now, to complete the table, what you have to do is you can substitute, all right, the value of x for these numbers. But when you have the x exponent, you will be saying 2 to the negative 2 power, which is going to be a fraction or decimal. So just for you, not to make you suffer, what you have to do is just put it in the calculator, right? Remember, your calculator is supposed to be like with the memory clean, so it's easy for you when you start graphing, all right? So remember, it's usually second plus 712. So my is already clean. So what I'm going to do, I'm going to graph the parent function, which is y equals 2 to the x. So I'm going to go to my y equals, and here now the base is going to be 2, number 2, and my instruction says to put the exponent, you go to up arrow button, this one, and you're going to type the variable x. Now remember, in this case, every time you have something like this type of calculators, you're supposed to move the arrow so you can bring back to to the bottom, because if you want to add something else in here, that will be considered exponent, the whole thing. So every time you have this type of calculators and you get this type of equation, make sure you hit the arrow, okay? this button, so we can come down, because when we start adding stuff, if it's going to be something on the exponent, so you don't have to bring it down. But if it's something that's going to be on the bottom, then you have to bring it down. And you'll see what I'm talking about. So this is how the graph is going to look, okay? That's the graph of the exponential function, and that will be the main function, all right? The parent function. So something's going to happen when we add stuff. So what I need is the table, all right? So I'm going to go from -2 on the x-axis to +2. So we'll go to second graph, and we go, because mine is already set up from the very beginning, it's begin from 0. But because I need to go to up to -2, so I'm going to go up 2 more. And you notice, -2, I come out with 0.25. When it's -1, it's 0.5. When it's 0, it's 1. Then when it's 1, it's 4. And when it's 2, it's 8. What's going on here, guys, is doubling up. So when you have an exponential function, you can just add the value that you've been getting, or you can just multiply that value times 2. I'll go more into details later on, okay? So let me write these numbers right here and put them on my table. So this is 0.25. This is 0.5 of 50, 0.50. That's going to be 1. That's going to be 2. That's going to be 4. So this is what I'm saying. You can either, like your next number, what you're doing is you're multiplying times 2. So 2 times 1 is 2. 2 times 2 is 4. So 4 times 2 is 8. So the number will be 8. And 8 times 2 will be 16. 16 times 2 will be 32. So you actually time it times 2. All right? Or you can use, I think that's the best way to remember. All right? Just times 2. So now let's graph those numbers. All right? Now, remember, in the graph, in your graph, you're going to be able to make sure you don't touch the x-axis, because if you notice here, when x is -2, which is right here on the left, y is 0.25. So you go like a little bit above, right? Not in the middle, because that's something else. Like a little bit above the x-axis. Now, when it's -1, which is here, is 0.5. So that you can go right in the middle. Okay, if you can just like calculate where that's going to be. The thing is that it cannot be on the line, like on the x-axis or any of the other line, because they are decimals. Now, from here on, everything is a piece of cake. So when it's 0, that's going to be 1, okay? When it's 1, that's going to be 2, because remember, it's doubling up. When it's 2, that's going to be 4, 1, 2, 3, 4. And just to make a very nice graph, I'm going to go one more. When it's 3, so 4 times 2 will be 8, right? So that will be 8. 1, 2, 3, 4, 5, 6, 7, 8. And the next one will be 8 times 2, 16. That's what I'm talking about. Every time you're going to add points, you're going to just doubling up. So now, when you connect the points, be careful. Make sure you don't touch the x-axis, because exponential functions never touches the x-axis, never, all right? So what I'm doing is, I'm connecting my points, and you see the gap that is being created. The gap is getting bigger. So from 1 to 2, it was this much. From 2 to 4, it got wider. So from the other one, going to be wider. So every time it's increasing, the gap is getting larger. All right, that's what is called exponential function, because it's growing up really, really fast. So now we're going to do the arrow, because that goes into infinity, and I'm going to label. All right, this is my y equals 2 to the x. That is my parent function. So before I stop doing anything else, you're supposed to know some kind of definitions, right? And the first thing, what they're doing here, guys, they just ask you to find the rate of change, which means slope, okay? And this is just for you to remember, that how to calculate the slope. Now, they want me to find the rate of change from the interval 1 to 2. Remember, this is the x values. So that means when x is 1 and when x is 2. So I'm talking about these two order pairs. There's two ways you can do it. From x, so that's going to be my x1. And that's going to be my x2. That's going to be my y1. And that's going to be my y2. So to find the slope, remember, you're going to use the formula. Remember the formula? Y equals y2 minus y1 over x2 minus x1. But you don't have to do that, because you can find the slope just from the table. Remember, we're looking for this rate of change between 1 and 2. So when x is 1, and x is 2. So what I'm looking for the rate from this point to that point. Because when x is 1, this is my y. When x is 2, that's my y. So what I'm doing is, how did I get from this point to that point? Okay? And you see that I went up 2 and over 4. So the slope for that interval is going to be 2. Now, if you don't know how to do that from the graph, you will do 2 minus 1 over y minus 0, which is equal to 2 over 1, which is equal to 2. You know how to use the formula, so I'm not going to waste time on that. Let's say if they would ask you, what is the rate of change from 2 to 3? So you will be looking for the change from here to here. And you will go up 4 and 1 over. So the thing is, like, the more points I graph, the bigger that slope is going to be, So that's it about the slope. That's something they already know. Now, the y-intercept. The y-intercept, I can get it from the table, or I can get it from here. From the table or from the graph. Remember, from the table, the y-intercept is always when x equals 0. So the y-intercept is 1. Now, be careful, because if sometimes they ask you for the y-intercept, so your answer should be 1. You can get it from here, or you can get it from here. You can see that it goes when it's 1. Or they might ask for the coordinates. So if they ask you for the coordinates, it's supposed to be 0, 1. So on the test, they might give it to you just 1, or 0, 1 is the same thing. Now, asymptote. Asymptote is the line that the graph is approaching. Okay, so let me read the definitions. Asymptote is the line that the graph is approaching. I think approaching is two p's. Okay, what do they mean by that? If you go this direction, okay, the graph is going to the infinity. Now, if you go in this direction, you can see, all right, you can see that the graph is going to go getting close to the x-axis, all right, but it's never going to touch it. Never ever. So the asymptote is the line that the graph is approaching, but the graph is never going to touch it. So now you have two options to answer. The asymptote for this is going to be the x-axis, all right? Because if you notice, it's approaching the x-axis. But remember, the x-axis is an equation, all right? The equation of the x-axis is y equals 0. So on a test, you might see, instead of seeing the x-axis, you might see the line y equals 0. So there's two ways you can answer, okay, the asymptote. Either x-axis or line 1 equals 0. Because remember, the x-axis is a horizontal line, and horizontal lines goes to the y-axis. The y-axis is a vertical line, so the equation of the y-axis is x equals 0. Remember that? So this one is like saying x equals 0, because both axes has their own equation. So the x-axis, the equation is y equals 0. The y-axis, the equation is x equals 0. Okay? So for this other one here, we are going to do the same thing, and we're going to graph them here, because here we will start doing transformation. So let's take a look at the first one. Okay, look at the first one. The first one, we have y equals to the negative x. So if you compare this to the parent function, the only thing we did is that the x becomes negative. What happened when the x becomes negative? I know what happened, but I want you to discover that with me. So the first thing you're going to do is to graph that and find the values of y when x is negative 2 until positive 2, that interval, right? So I'm going to go to y equals, we're going to eliminate that, clear, and let's just type 2 elevated. Remember that to put the exponent is going to be this button right here. So you already typed 2, up arrow. Now, because it's negative x, you're supposed to use this button, guys, this one right here, okay? The one in parentheses, not the minus sign. So we're going to do that. and you're going to type the letter X. So there's my equation right there. And look what's going to happen. You look at the graph because that's why you have to graph. If I go to graph, look what happened. Now my equation, instead of going that way, now it's coming this way. Instead of going up, now it comes down. So remember that. Every time that the exponent, which is the x, is negative, that's going to be a reflection over the y-axis. Because if you remember the parabolas, if it was happy face, it would reflect over the x-axis, right? Because that would become sad face, and vice versa. If it was sad face and I change it, it will flip over the x-axis to become happy face. This one is going to flip over the y-axis and also over the x-axis. So you have to be very careful. You cannot say only it flipped. You have to make sure you say flip over the right axis, all right? So in this case, it's going to flip over the y-axis. So I can already answer some of the question right here. Look, from the calculator. So graph changes, okay? So you're gonna write here, flip over y-axis. That's what happened there, okay? It flips over the graph change, flip over y-axis. Or you can say reflect over the y-axis, it's the same thing. Now the y-intercept, I can also find it because if you notice here, the y-intercept, where does the graph cross the y-axis? Right here, when it's 1, okay? So the y-intercept, you can write 1, or you can write 0, 1. And the asymptote, just from here, this line is approaching which one? This graph is approaching, again, the x-axis. You're never gonna go, but you can see it go in that direction right there. So the asymptote here is gonna be either x-axis, or you can write y equals 0. Either one. And you have both options. You don't have to write both in the home runs. Just write one or the other one. They're both going to be correct. So now, let's say if you didn't know these answers right now, okay? So do the table and do the graph and you will be able to see it. So to get the numbers so I can plug in, I have to go to my table, second graph, and I'm going to find from -2, you see, to +2. Same thing. So what happened now? The numbers going in reverse. Now when it's -2, y is 4. When it's -1, y is 2. 0, 1, so that's my y-intercept, you know, that's what I got it from. And this becomes I'm sorry, my bad. 0.5 or 0.50 is the same thing, and that's 0.25 or 1/4. All right? So let's graph those. If you notice, guys, look, from the table before, here from the parent function, the number will going up. Now from here, the numbers coming down. So let's graph this point. When x is -2, y is 4. So -2 should be right here. So we'll go up to 4. 1, 2, 3, 4. All right? I'm getting from the table right here. When it's -1, it's 2. So -1, 2 is going to be here. If you notice, the y-intercept is going to be exactly the same as the parent function. So the other one, when it's 1, is 0.5, so right in the middle. And when it's 2, it's 0.25, close to the x-axis, but not on the x-axis. And just to make, like another clear point, I'm just going to go one step farther, right? So because this is 2, so when it's 3, -3 is supposed to be 8. So that's supposed to go in here. It's almost a reflection of the other one, if you notice. Look, this with that, that with that, that with that, and the same thing. This with that, and that with that. So I only did that extra point because I just want to get a better graph, all right? So I can do it more accurate. So I'm just going to connect my points, okay? Trying to do it as more accurate I can. And here it is, all right? And you do like a little tiny arrow. And this one, of course, arrow because it comes from infinity, because it's coming down. So I'm going to label it. This equation is y equals 2 to the -x. And I can clearly see the asymptote. The asymptote is approaching to the x-axis or the y equals 0. And my y-intercept is positive 1 or 0, comma 1. All right? So now let's do number 3. Okay? I'm using different colors so you can visualize better. So I'm going to do number 3. So number 3, what am I doing now? Now what's negative is the base, negative 2. Okay? So remember, when we have exponential, this number cannot be 1. Okay? It has to be greater than 1 or less than 1, but not 1. So what's going to happen now? I know what's going to happen. Okay? But you probably don't know. But that's going to be reflected over the the x-axis. I'm telling you, I know this because, of course, I have taught this lesson many times, so I know that if I make that negative, now, remember, from the parent function, now the parent function is going to come down this way. That's what I told you before. When you say it flipped over, you have to make sure you label which axis is flipping over. And this one is flipping over the y-axis. This one is going to flip over the x-axis. So let me do it with black, rather, because I want to leave they're going to be the only one that's going to go reflected over the x-axis. So let's find the values, all right? So let's go to y equals again, and let's clear that up. And remember, I'm doing my negative term. So when it's negative, you always use this negative button right here. So we're going to do negative what? 2, okay? Up arrow, which is the caret key right here. It's called up arrow x. And let me graph that. See, I don't have to exit out because I'm not putting anything else. So let's just do graph, and that's how my graph is going to look. And you can see that now it's reflecting over the x-axis. I can see that my y-intercept is going to be now negative 1. And also my asymptote, because remember that the line is going in this direction to negative infinity on the y-axis and positive infinity on the x-axis. But so that means that this one is approaching the x-axis again. So my asymptote there is going to be the y equals 0 line or my x-axis. So let's answer that first if you want to, or the way we can do it after. But since I already know, I'm just going to answer my question right now. So here, graph change, you're going to write, I'm going to use reflector now. Reflect over x-axis. You can write flip over, it's the same thing. I'm just using different words, so everybody, so you might forget about the word flip, but you remember the word reflect, or vice versa. So you have two options. I know my y-intercept is going to be negative 1 because I saw it on the graph. But remember, if you're not sure, so find the values of y and you'll be able to see it. And or 0, negative 1. Remember, either one is correct. Now the asymptote is going to be the same one. The x-axis or the equation y equals 0. Now let's graph it and find the numbers. Okay, so because I already graphed, to get the values, I'm just going to go to second graph. And I'll be able to see that when it's negative 2, what do we have? Negative 0.25. When it's 1, negative 1 is negative 5. Then we have negative 1, negative 2, negative 4, negative 8. You see it's doubling up. From here, look, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Remember, exponential, always doubling up, doubling up. So let's put these numbers right here. So it's going to be negative 0.25, all right? Negative 0.5 or 0.50 is the same thing. Negative 1, negative 2, negative 4. And I'm going to use this negative 8 only because I want to, make the graph looks nicer. So let's graph those points. So when x is negative 2, what is it? Negative 0.25. So that means that negative 2 is right here. So negative 0.25 is going to be like close, almost touching, but not, right? The x-axis. Now the other one is -1, it's going to be 0.5, so it's right in the center. When it's 0, it's -1. You see, that's my y-intercept right there. When it's 1, it's -2. When it's 2, it's -4. And I told I was going to get an extra one. When it's 3, 5, 6, 7, that was here. And the other one will be 16, so it will be farther down. So you know, that's what I'm talking about. It's actually growing. So I'm going to connect these points, and I'm going to make sure I do my little arrow, because that's my asymptote right here. Or should I open? See if from this side I'm not that good, but I did it. So that's where the graph is going to. So you can clearly see here that my y-intercept is -1, and my asymptote is the line y = 0 or the x-axis. Now let's label that. That's the graph of the function y = -2 to the x. I have 2 more to go. All right, let's use now the green. Now, this should be easy, guys, for you, because just by looking at it, you can tell. Remember, this is the parent function, all right? So what I'm doing is I just subtracting 1. So that means that this is going to bring the graph down, okay? 1 unit. If that would have been plus, it will move it up 1 unit. So I know already that that's going to be my graph change. So I'm going to write it because I already know, you know, based on the other lessons, you know, parabola, what's going to happen when we, you know, when we change the value of c, which is the constant. That means either goes up or down. What happens when we change the value of x, not the value of x. So when we have the numbers next to the x, if it's positive, go to the left. It is negative, goes to the right. So in this case, it's going down 1. So I'm going to write here, graph moves down 1 unit. Okay. What the y-intercept going to be? The y-intercept is going to be -1, because that's, remember the equation y = mx plus b? So always the constant number on any formula is always the y-intercept. Remember the line y = mx plus b. B, which is the constant, is going to be the value, the y-intercept. Parabola, ax squared plus bx plus c. C, which is the constant, is going to be the y-intercept. So here, -1. In this case, if you notice here, the y-intercept, okay, is going to be then -1. So you can write -1 as a y-intercept, or you can write 0, -1. Now, I know now, all right, that my asymptote is going to be the equation of the line y = -9, and I'm going to explain to you why. So for this one, the asymptote is not going to be x-axis or y = 0, okay? Because now remember, if the graph is going to go down 1 unit, so now that graph is going to be approaching this line, y = -1. So the asymptote here is going to be y = -1. The line, horizontal line, and I'm going to explain to you why. So now let's just find our values. And first of all, we have to graph it, clear that up, and just type 2 to the x, all right? Now remember, guys, that's what I'm talking about, because now I have -1. I have to make sure, okay, I use my arrow to get down the exponent, because if I continue typing there, everything's going to be on top. Everything's going to be considered exponent, so I must hit this button. So I hit the button to exit out, and I'm going to type now minus here. Now we're going to use the minus button because it's a subtraction, -1. Remember, it's always a big difference, guys, between the minus and the negative sign, so be careful. If you have something crazy like an arrow, maybe that's what you did. Maybe instead of using the minus sign, okay, instead of using this, you use the negative sign. So let's graph and see how the graph's going to look like. So if I graph it, okay, you see now the asymptote is not over the x-axis. You see, it's below the x-axis. So that means that it's approaching the line that is below that, which is y equals -1. So therefore, that's why my asymptote now is y equals -1. You can tell that it's not on top of the x-axis, it's below. So let's just graph now those points. How am I going to find my point? You go to the second graph, and when it's -2, you have -0.75, you have point -5, 0, 1, 3, and 7. I'm going to explain to you why now you have odd numbers. So when it's -2, you get -0.75. When it's 1, you got -0.5 or 50. When it's 0, you get 0. Okay, I made a mistake, guys. Yeah, so that's my y-intercept is 0, 0. My bad. When it's 1, is 1, and when it's 2, is 3. So when it's 3, it's 7. I'm going to explain to you why I'm writing that. So, like I said again, I made a mistake. The y-intercept is 0. Sorry, guys, 0. So just ignore this, please, because I don't know what I was thinking. Let me just do that again and just rewrite it freshly so you don't get confused. You see what I mean? I made a mistake, you made a mistake, all right? So if you're not sure, like now, if I wouldn't graph this in the calculator, I would be wrong, all right? But sometimes that's what is very important for you to graph and to find the number from the table. Because now when x is 0, y is 0. So my y-intercept is 0. Let this part get dry so I can write the number, and we can actually finish the problem. So let's go graph, then we'll come back to write the y-intercept. So when this is -2, right? Okay, when it's -2, -0.75. So that means close to -1, all right? So that has to be right here, guys. This is -2. So now this is -0.75, because this line right here is my y equals -1. Okay, so it doesn't matter which way, if it's going up or if the line goes up or down, the asymptote is going to be different. It's not going to be the x equals 0. I'm sorry, it's not going to be the x-axis, neither the y equals 0. Okay, only when it goes up or down. If it moves to the right, to the left, that's not going to change. Okay, so let's do this. So when it's -1, according to here, right, -1 is -0.5. So that's going to be right in the center. So it's exactly the same point that I see that's right here over that line. Now when it's 0, 0, so there's my y-intercept. When it's 1, it's 1, it's right here. And when it's 2, okay, when it's 1, it's 1. When it's 2, it's 3. So 2, 3 is right here, close to the other one if you can see it. And when it's 7, when it's 3, it's 7. 1, 2, 3, 4, 5, 6, 7 is right here. So it seems like they touching, because remember, this line right here doesn't go exactly through 7. The way I graphed it is, that it makes it look like it goes through 7. But anyway, this graph should go like this. See, if I don't give you that point, that extra point, I will finish my graph right there. That's what I went that extra point. So I can see that that line goes through that part right there. And of course, here in this end is approaching the -1. All right? So let me just label that. That's going to be y equals 2 to the x minus 1. So let's rectify here. So now my y-intercept here was 0, okay? The one that I made a mistake. And the coordinate will be 0, 0, okay? I apologize for that. But remember, we all humans, we all make mistakes. So we have one more to go. So look at the difference in this one. This is the parent function, 2 to the x The only thing I subtracted 1. Now, this is the parent function right here, but now the 1 is on the exponent, is next to the x. So that means that the lines graph is going to move horizontally, not vertically. When it's something like this, okay, I'm gonna write here, this is horizontal movement. Okay, when it's something like this, it's vertical movement. I'm trying to give you all the information that I can so you can remember. Okay, so it's two different things. Now you remember that, right? When it's positive, it goes to the opposite side, because this is +1, it's going to move to the left. If that would have been negative, it will move to the right. Okay, remember that. Same thing with the absolute values, same thing with the parabolas. So all these graphs, square root, cube root, all the graphs that we have done in all the transformations are the same rules. Move down, move up, to the right, to the left, it shrinks, it opens up, it gets bigger, it goes up, it gets higher, it gets lower. So it's so many changes that you have to try to remember. Now, if you don't remember what you do, you graph the main function and you graph the other one, and you'll see the difference on the calculator. So here, I know them because that's the only number I'm adding. So in this case, the graph's going to move to the left because that's positive. 1 unit, okay? Now, I'm not sure about the y-intercept, right? But I know that the y-intercept, I have to graph it so I can see that. And the asymptote also, remember, is going to be x equals 0 or the x-axis. So you can put x-axis or y equals 0. The only time that the asymptote changes is when it moves up or it moves down. If it moves right or left, the asymptote always going to be the x-axis or y equals 0. Remember that. So the asymptote only changes when the graph moves up or moves down. Okay? Right, so let's find the values of 2 of that equation, okay? So I go to y equals, I'm gonna eliminate that. Now, when I put my equation here, I don't have to X it out, okay? Because I need the one to be next to the x as exponent. So we're gonna go to 2, up arrow, x. This is what I mean. I'm not gonna use this button right now because the +1 is next to the x. So I'm still gonna be typing +1. And if it were to be another number on the bottom, then I will exit out, okay? But remember, if it's up, don't exit out until you enter all the numbers that are next to the x. So I'm gonna go to graph. You to see how the graph is gonna look like. You can tell, that's my y-intercept. I don't know what the value is. And this is my asymptote. And you see it's approaching the x-axis or y, the line y equals 0. So let's go find the values, okay? So I can do my graph. So when it's -2, it's 0.5. When it's -1, it's 1. Then when it's 0, it's 2. You see? When it's 1, it's 4. And when it's 2, it's 8. So let's graph those. -1 is going to be -2, I'm sorry, 0.5. -1 is +1. 0 is 2. When it's 1, is 4. And when it's 2, is 8. So now, I can see that my y-intercept is +2 or 0,2 because it's right here. But if I'm not sure, so let's graph it, I will be able to see it on the graph. So when x is -2, right? Y is +5. So that means that that's going to go a little bit above, like in the center right here. Okay, because this one, I guess, when I did the arrow, it looks like the whole point, but that was the arrow that I did before. Now, when it's -1, it's +1, so the other one's going to be right here. When it's 0 is 2, which is there, that's my y-intercept. When it's 1 is 4, so 4 is right here. And when it's 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to connect the points. Okay. So there's my asymptote. Look. Okay, the red one is here, the last equation that I did, which is y equals 2 to the x plus 1. So I have my 5 equation there. I have the parent, which is the blue. Then I have number 2, which is the light blue. Then I have number 3, which is the black one right here. Number 4, which is the green, and number 5, which is the red. Now, from the parent function, this is what I mean. Because remember, according to the graph here, right? It moves to the left 1 unit, so that's what happened. Look, I'm gonna work with with the whole numbers. Look, that was my first point, all right? That was the first point when it was 0, 1. Now that point is right here, move 1 to the left. That was the other point right here. When it was 1 was 2, now that point is right here. Can you see what I'm doing? Look at this point was right there. Now it's right here. It's moving 1 to the left. That was the other one. I was here and 1 to the left. So that's all is to it. Now the other one that I moved down 1, that's the green one. That's the parent function right here. Because it moved 1, now this one, which is the y-intercept, now from here went down here. This one came down here. And you see every point moves down 1. So I know it's a little complicated, a lot of things to remember, but just listen to my advice. If it's easy for you, fill the table first, find the number from the calculator, graph it. I don't even think you have to graph on the homework, but if you do graph it, they will be able to answer this question from the graph. But I'm not sure, I think, if I'm asking you that. So just in case, all right? So now let's turn on the back, which is now going to be a little lighter because that was all transformations. So now in the back, we have multiple choice. I mean, the homework actually is all multiple choice. So what they're asking you here is to match each curve with the correct equation. So all these graph right here have their own equation here. This is what you have to do. You can graph one at a time and see which one looks like this. Or you can use common sense, all right? And take a look. Look at this one. This one right here looks like the parent function, right? Because it goes through that. Okay, so this is what I'm talking about. Remember when I said to you that b cannot be 1? It has to be either greater than 1 or less than 1, but never 1. Okay, so here they're asking you to graph y b to the x when b is greater than 1. So let's imagine that b equals 2, all right? So now you're going to substitute this value of b for 2. So this is like saying, let me see if you can see that. Hold on. This is like saying now the equation becomes y equals 2 to the x. And if you notice, that's the main function. All right, so the graph of the main function is this one. So that should be number 1. Okay? Now, this one is a little easier, guys, because according to this equation right here, remember the only thing is, like I say, it had to be, ignore this, that had to be greater than 1. Okay, so what they're telling you here is that if you make this 2, all right, greater than 1, let's make b equals 2. So let's write the equation. Y equals, right, 2 x to the negative 3 minus 3. All right? Because what I'm doing, I'm following my restrictions. They clearly say that b has to be greater than 1. So I pick 2. Always pick the following number. Don't pick a bigger number, right? So this is the main function, 2 to the x. So what I'm doing is, because I add negative 3 next to the x and minus 3 on the bottom, that means that the graph is going to move down 3 into the right 3. So the one that moved down 3 is this one, look, because now, no, I'm thinking it's this one, right? Because it moved down 3 and it moved to the right. This one it moved down only. So you can clearly see that this one, if it goes down 1, 2, 3, and it moved down, it may move to the right 1, 2, 3. So it has to be this one. So this is choice 2. Or you can just put that in the calculator and you're going to see that it gives you this function. I'm just doing that because I don't want to waste too much time. Now let's do this one. If you see this one, they're asking you b to the x, but b has to be a number between 0 and 1. You see, never 1, never 0. It has to be a number, so it has to be a decimal. So I can say b equals to 1/2. So if I graph that, it will be y equals 1/2, I'm sorry, yeah, to the x. And if you graph that, that will give you this one right here. And I'm going to do it for you because you will say, Mister, but that, I'm going to explain to you why you're going to get confused. If I graph that, I go to y equals, all right, and I'm going to type 1/2, 1 divided by 2 elevated to the x, all right? It's right there. And look what happened. If I graph that, it's this one right here. But you're probably thinking to yourself, but in the one before, I thought that only when the x is negative, that it will come down this way. That will reflect over the x-axis. I mean over the y-axis. Because if you notice this one is number 2, which is the blue one right here. And that's reflection over the y-axis. But in here, the x is not negative, right? But the base is a fraction. It's a number less than 1. That's why also makes it to reflect over the x-axis, over the y-axis. So therefore, this has to be what choice? That has to be choice 4. Why? Because according to this, look, this one moves down only 3 units down. It doesn't go to the right or to the left. So it has to be this one because this one only came down 2. Remember from here, which is this is the y-intercept of the main function. So if it goes down 3, 1, 2, 3. Now the y-intercept is here, 0, -2. All right? So now if you want to make sure this is b equals 2, because remember, b has to be greater than 1, and you type the equation y equals 2 to the x minus 3. The difference between these two is that here I subtracted 3 on the x value. I mean, like, you know, in that expression right there. And in here, I only subtract 3. So that means that it will go down 3. But then again, the only thing you have to do is just graph one of each, all of them in the calculator, and you'll see how the graph looks like. Now, let's go to this one. Given the parent function f of x equals to 3x, remember parent function, write the equation with the given descriptions. Okay, now, remember the asymptote, when we're talking about the asymptote, we're talking about the y-intercept. I mean, not the y-intercept. That means that it goes down, okay? So that means down 3 because it's -3. Remember what I said before, okay? The asymptote is only changes when it goes up or it goes down, because the asymptote of the parent function, which is this one, is always y equals 0 or the x-axis. So here, even though, okay, if it goes down 3, that's going to be different asymptote. And 3 units to the right, that means that's going to be -3, okay? Because this one is moving horizontally to the right, so it's going to be -3. So now we can write the equation. The parent function is f of x equals 2 to the x, okay? That's my parent function. Now, because it moves to the right 3 units, so it's going to be -3 right here, because that's when we know if it moves horizontally in the x-axis. Now, and it goes down 3, so it's -3. So the equation is f of x equals 2 to the x minus 3 minus 3. Now, the asymptote here is +1. That means that the graph goes up 1. And it moves horizontally 2 units to the left. So that has to be +2. So the equation is going to be f of x equals 2 to the x, which is my parent function. Now, +2, because remember, you always start with, with the movement to the right horizontally, then vertically, which is +1, because it goes up 1. Now, vertically shift down, that means -4. And horizontally, 5 units to the left, they're going to be +5. Remember, horizontally means x, vertically means it moves on the y, okay? So my equation is going to be f of x equals 2 to the x plus 5 minus 4. Vertically shifts 2 units up, so going to be +2. Remember, that's y. Horizontally is x. 3 units to the right, so they're going to be -3. So my function is going to be f of x equals 2 to the x minus 3 plus 2. Now I'm going to give you the equation, and you're going to write something like that. Oh, I'm sorry. Yes, you're going to write now everything verbally. All right. So the thing is, this is the parent function. So what's going on with this function? So that means down, okay, and that means left. So the graph shift vertically, or you can write moves down 4 units and 5 units to the left. All right. Now here, that's up, and that's to the right. So let's write differently, all right? The graph moves to the right 4 units and up 5 units. You can use different words. You can use shift, up or down, right or left, move, up and down, right or left, or, many things. Now this one, because of this, is gonna go down, left, and that's gonna make it narrower. So the graph, you can write shift again, shift down 1 unit, moves to the left 1 unit, and it shrinks. And it shrinks because remember, this one makes it, like the parabola. Remember when the number was greater than 1 in the parabola? It will stretch, it will shrink, it will get narrower, and when it's a fraction, it will get wider. So here it's going to be the same thing. Here it's going to be up to no movement horizontal, no movement at all. Only because of that, it's going to get wider, okay? So you're gonna say the graph moves down, I'm sorry, up, my bad. Moves up to unit and it gets wider. All right, let me erase down here because I don't want to get messed up later on. So that concludes the lesson. Remember guys, if you don't know, if you don't see the changes, graph the main function on y1 and graph this in y2. And when you graph it, you're gonna see that the main function comes first, right? And the other one comes after. Just to show you what I'm talking about, I'm gonna graph the last one so you can see what I'm doing. So my suggestion is this. Eliminate that one, right? Let's graph the parent function, 2 up arrow to the x, all right? And I'm gonna graph the bottom one, okay? So I'm gonna put, sorry, I wanna see when you see better because the light is doing a reflection. All right, I'm gonna do then 1 divided by 4, open parentheses, 2 to the x, okay, close parentheses. No, let me exit out first, close parentheses, plus 2. This is what I'm talking about. If you don't see the changes, just put the equations and graph. Here comes the parent function, look. Now here comes the other one, look what happened. It went up and it got wider, okay? And the other one, if I were to graph this one, if I were to graph this one, you will see that we're getting narrower. Let me do that too, all right, just for you. So let me do that in number 3, right there, y equals 3. So the equation was 3 parentheses, 2 up arrow to the x plus 1. So let me exit out, close parentheses, minus 1, okay? I put the other one. So look what happened now. See the other one? Look. So this one is the parent function. When I got the fraction, it got wider, and when I got the other one, it shrink, okay? So you can do that so you can explain what happened, all right, during the transformation. Okay, guys, this lesson is going to be for tomorrow, and I mean for Thursday, and the homework is going to be for Friday, okay? So just take your time and good luck.